Okay, we're going to do problem number 43. And the problem reads, is the function f of x equal x squared minus x plus 1 ever negative? And then you want to explain that. So you can't just answer yes or no and be done with it. And there's several approaches to this. You could certainly take a pre-calculus approach to this problem. And you can notice from the graph, it's x squared. That's a parabola opening upward. You might want to complete the square. You might want to find the vertex, put it in vertex form, find the vertex. And that vertex, because the parabola opening upward, is the lowest point. And see, is that vertex positive or negative? If it's positive, and because that's the vertex and the parabola opens upward, then your function will never be negative. If the vertex is 0, same argument. And if the vertex is negative, well, then clearly the function could be negative. So you could put it, pre-calculus, put it in vertex form, and find it that way. We're going to take here just our calculus approach, which is, let's find the minimum of our function. Same thing, we know it's a parabola opening upward, so there's a vertex. We know it's going to have a minimum. Just looking at this, again, this positive x squared right at the front kind of gives it away. All right, let's take the derivative. The derivative of this function, very nice, is 2x minus 1. I set that equal to 0. I'm looking for critical points, and I'll see I have one critical point when x is a half. I'm going to take that back to the function. So I'm going to sub that into the function. This is the vertex, or in terms of calculus, this is my minimum. I haven't proven it's a minimum yet, but we'll see that also. I'm going to plug this back into my function to see what the y-coordinate is. So I get 1/2 squared minus 1/2 plus 1. So it looks like 1/4 minus 1/2 plus 1. And that looks like 3/4. So our critical point is when x is a half, and we've got a y-coordinate of 3/4. Okay, we know it's a parabola opening upward, but let's just complete this deal anyway. Let's take the second derivative, and my second derivative is 2. My second derivative is positive, so second derivative is positive. That means my one and only critical point is a min. So x equals 1/2 is a min. Since I only had one critical point, since it's a min, I can say with all confidence, this function never gets less than 3/4. So to answer my question, is the function of x equals x squared minus x plus 1 ever negative? I'll say nope. F of x is always positive. I can go a little stronger if I want. F of x is always greater than or equal to 3/4. And I've explained it here in my reasoning by taking the derivative, getting the critical point, and showing that's a min, and finding that y-coordinate at the critical point, and showing that that is positive. That completes the problem.